Hi everyone, so our next lesson is all about linear relations, and that's what we're going to work on for the rest of the term. So this is just a really brief introduction, reminding you what you already know. None of this is actually new today, but you may have forgotten some of it. So what is a linear relation? It's just a way of relating two variables in one equation. So for example, x and y. It can be any two different variables. It doesn't matter what the letters are. It's just a way of making them work together. So a really simple way to draw a linear relation is to use a Cartesian plane. Remember, that's the x and y axis. And when you do draw a linear relation this way, they must form a straight line. Otherwise, it's some other sort of relation, not a linear one. So, and one other thing I wanted to remind you about is some other terms that are going to be important, but you may not remember, is the x-intercept and the y-intercept. Now the x-intercept is where the graph or the line cuts the x-axis, and at that point the y value is 0, and the y-intercept is where the graph cuts the y-axis and where the x-intercept is 0. And if we have a look at this little table and graph underneath, you can see that that's true. So where x is 0, we've got y is equal to 4, and that is the y-intercept. So notice that the x is 0 there. And if we have a look at the graph next to it, you can see that our x-intercept must be 0, otherwise it would be further to the right, and our y-intercept is, our y value is 4 there, so it's where it cuts the y-axis. And similarly, the x-intercept down here is where we've got a value for x, but our y is 0. Otherwise, it would be further above. Okay, so hopefully you remember that. So there are a few ways we can draw a linear graph or a linear relation. And one way we can do that that's pretty simple is to create a table of values and substitute numbers into that equation and solve. So we're really just using algebra here, and we're plotting them. So continuing our work with algebra. So let's look at this little example. So using -3 is less than or equal to x, which is less than or equal to 3, construct a table of values and plot a graph for these linear relations. And the graph, or the line we're going to plot, is y equals -2x plus 2. Now the solution's already here for you, but there's a few things I wanted to point out, and I wanted to show you where the values came from. So -3 less than or equal to x less than or equal to 3 just means we want x values from -3 all the way up to 3. So it's saying our minimum x value is -3 and our maximum x value is 3. And we're going to put those values into our equation, y equals -2x plus 2, and it's going to give us values for y, which will allow us to plot them. So the solution is there, but I thought I would show you where the first one comes from. So, for example, let x equal -3, and we're going to put that into our equation to find a value for y. So it's just substituting, rearranging, solving exactly what we've already been doing. So our equation is y equals -2x plus 2, but we're going to put -3 in instead of x to get a value for y. So that equals -2 times -3 plus 2. Now, order of operations tells us to do the multiply first. So -2 times -3 is, of course, +6, because we've got a negative times a negative. And our value when x equals -3 is 8. And you can see that's just been entered into the table. So we've done all of this before. This is just a simple reminder. And remember, once you've done that, you need to go away and plot it onto a Cartesian plane. So remember, Cartesian plane is just the x and y axes. Remember, the x value is plotted first on the horizontal axis, and the y value is plotted on the vertical axis. So you go across and you find that value. So x first. So -3 in the x-axis is going to be here. So we go there, and then we move to our y position, and +8 would be up here. So first of all, you go 1, 2, 3, and then you go up the 8 places, and you put a mark or a dot usually at that place. So you would keep going and plot all of those values to get all of them plotted, and then you would draw a line between them, or through them rather. Notice that there's arrows on either end, so that's just saying the line is keeps going in either direction. And the other thing that this solution doesn't really have, which we should have, is we should write our rule on our graph. So, simple reminder, you've done this stacks before. I know you guys can keep going with that. So what you're going to do from here is practice doing this stuff, just to remind you what it was on the worksheet. No need to do this now. I'm going to give you a hard copy in class, but if you miss it, or you don't have the worksheet, or you lose it, there's a copy here on the OneNote for you that you can download as well. One last thing I wanted to remind you about, and it's really quick, is that you can also use the equation of the line to see if a particular point falls on it. And it's easy to do. All we need to do is substitute that point in as our x and y values and see if it makes the equation true. So remember, x, y, they're always written as x and y. So we're going to put these values in and see if that's right. So it's you may want to split it up and do it separately, or you can do it as one. So let's do it as one this time. So instead of putting y, we're going to put 4. And instead of putting x, we're going to put -2. So negative 2 plus this time plus 2. So we need to simplify to see if that's true. So negative 2 is positive 2 plus 2. So of course, okay, therefore it's true. Therefore, -2 and 4 falls on the line y equals -x plus 2. So you could choose to split both sides and work out the left-hand side and then the right-hand side and then compare, or you can write it something like this. Up to you. So the only other thing we're going to do today is do a few questions on this. Questions 6, 7, and 11 is a little bit different but uses the same type of techniques, and it's a little bit more complex. And that's it for today's lesson, and we're going to move on with linear relations and more work with that after this. All right, see you in class.